Hello everyone, so today my team and I will be explaining about tool marks in crime scene. So as for introduction, I'm Abdul Azir Rahman with matrix number 63007. So I'll be explaining about the tool marks. Tool marks is something that is left behind by the criminal on the crime scene. Okay, tool marks, there are three types of tool marks, which are indentation marks, abrasion marks, and cutting marks. Different type of tools produce different traces of marks. Hence, forensic around the world perform different type of analysis to identify them and classify them into each category. So there are several types of analysis can be made to identify the type of tool and the traces in crime.
For microscopic procedures, the following should be addressed prior to any microscopic comparisons. Review the laboratory protocols as needed. Complete the administrative requirements such as chain of custody, marking of evidence, laboratory case identifiers, investigative file identifier, examiner identity, and quality assurance. The laboratory safety protocols should be obeyed. The presence of trace evidence and follow laboratory protocol for collection should be determined. Examples of trace evidence include paint, glass, blood, bone, soft tissue, hair, fibers, wood, metal smears, masonry, and stone. The examiner should determine if latent fingerprint tests should be conducted prior to toolmark exams. Determine whether further tests should be conducted. If so, coordinate with the investigator. After addressing the requirements determined by trace evidence and latent fingerprints, the area marked with the tools can be cleaned. In microscopic comparisons, there are several items that should be considered when conducting microscopic comparisons. These include ensuring the stereo and comparison microscopes follow all requirements of maintenance and calibration. On both objective lenses, select a suitable magnification level for the comparison microscope. This setting is often 1 or 2 power of magnification. Make sure target lenses are locked in place. For both ocular lenses, select the appropriate magnification level. Usually, it would be in 10 power of magnification. It will produce a cumulative magnification of 10 or 20 power, respectively, when used with the objective lenses set for 1 or 2 power. Most examiners prefer this range to the lower end. Last but not least, use the same form and light source orientation for each microscope step of comparison.
However, when the evidence and the research toolmark cannot be compared on the basis of individual mark, the potential explanation for the inconclusive finding include the following, which is two separate devices were used to create the tool marks, harm done by the distortion, deformation, or loss of microscopic information in the tool mark. The instrument was destroyed or commonly used or exploited by the period of tool mark were made, and the various features of the classification can be present, and the potential solution that may be used under some cases to deliver improved microscopic accuracy under check mark, including the first one is perform both examination and the proof label end to end on their respective mount and re-examine them. Second one is smoke the evidence tool mark using magnesium smoke to enhance accuracy. This method is beyond the framework of the instruction and only be done by qualified investigator. And the third one is prepare for the checkpoint of a separate substance, likely a harder substance or material more comparable to evident element, and adjust the number, position, and angle of force used to build the test mark.
Hello, I'm Ahmad Tajrin bin Gurrahman and my matrix number is 63041. I'm going to explain on the comparisons of evidence, tool marks, and test marks. There's a few steps in approaching the comparison of test marks versus marks on evidence items. First of all, we have to do the preliminary procedures according to the lab protocols. And then we have to confirm that the evidence items bear class and microscopic value for comparison purposes. We also have to confirm that the marks are suitable for comparisons. The use of a stereo microscopic at a very low magnification is very excellent for this purpose. Moreover, we have to adjust the lighting of the comparison microscope to provide an oblique or grazing illumination over the surface of the marks towards the examiner. We also have to align the evidence marks with the test mark on the other side of the optical hairline of the microscope to confirm the consistency of the class characteristic.
There are several variables must be considered in order to maximize efficiency and effectiveness in the production of the test mark and basis for comparison against the tool mark made by the evidence tool. First, the way in which the device operated on the device mark surface, which is the operation used. Second is the area of the working surface of the device used. Third is the volume of energy used in the device. The position which in the working surface and the instrument have shift. This can be very minimal for certain device, like ball culture. For certain times, item there could be nearly infinite instruction, such as screwdriver, and the angle or direction of the instrument relative to the indicated surface, and the specific condition of the crime scene that could hinder whether the tool may be utilized.
Hi, I will discuss 2 points of evidence. The first one will be intercomparison. This type of comparison is used to link evidence items from multiple crimes to a single tool and includes the following steps. First, they will ensure that the evidence items are marked according to laboratory protocols, and then they will confirm the evidence item bear class and microscopic marks of value for comparison purpose and are suitable for comparison. They will examine the tool marks on both evidence items separately and select the one with the best quality individual characteristic. They will place the evidence item with the best marks on the right stage in an appropriate orientation, keeping the best marks in the center of the field of the view. They will index this best area using a colored permanent marker. And then, using low magnifications from 10 times to 20 times, they will examine the entire surface of this evidence item, looking for areas with most obvious individual characteristics. When such area is located, leave the right stage in that position. And then we place the second evidence item on the left stage as outlined, and then the both item will be aligned of its evidence mark to confirm the consistency of the class characteristics. If the class characteristics are different, the examination should end, and then if the class characteristics are the same, the examination should proceed. The second evidence will be analyzed by intercomparison of fractured object. Now, this section of the modules outlines a protocol for the comparison of fractured items, typically brittle metals, plastic, and other materials thought to have once been joined as a single continuous object. Fractured knife blades, broken screwdriver tips, motor vehicle components, except for the glass in front of the lighting, and many other similar items fall within this category. Examination and comparison of fractured items are not tool mark examinations within the narrow definition. However, they often involve the same evidence items that bear and produce tool marks. At some points, the crystalline grain structure of an object will fail when sufficient force is applied to the object. This failure will occur along the repeating patterns of atoms in the crystal structure of the object, and then the failure will be random, unique, and microscopically observable. Interestingly, when these random and unique failures occur, the high areas of the fractured surface of one piece will correspond to the low point of the fractured surface on the other piece. When viewed physically side by side using stereo microscope, this is very apparent.
Next, for reverse lighting technique, to document the fractured comparison, the objects are viewed side by side on separate stages of a comparison microscope. The fractured surface of each specimen can be made to appear as a mirror image of the other on each side of the optical hairline through the use of the reverse lighting technique. The results are very graphic and convincing in demonstrating that the two objects were once joined together, especially after the image documentation is generated. That's all from me. Thank you.
So as for a conclusion, these analyses are done in order to identify the tool mark accurately without giving the forensic misleading information. Alright, and then all in all, the tool marks analysis is one of the major roles in crime investigating a scene. The analysis made can decide which or what weapon were used in the crime, and we can classify them, identify them. Right. Bear in mind that analysis of tool marks will not be able to reveal the justice, but it will surely help in determining how is the crime being done using the tool, and then the choices from the tool itself will provide investigators with crucial information for them to conclude things. That's all from us. Thank you.